Hello friends, in this video I am going to discuss about types of reaction intermediates. Before we going to discuss about the types, right, let us discuss about what is an intermediate for the chemical reactions. It is just a chemically most reactive part or unit generated in the non-considered reaction is called an intermediate. What is meant by non-considered reaction? We have already discussed that if reaction carried out in more than single steps, right, those reactions are known as non-considered reactions. Single step reactions are known as considered reactions. More than one step reactions are known as non-considered reaction. In those reactions, right, chemically most reactive unit or part is called intermediate. Most of the organic reactions, right, we have to assume one thing, that stability of the intermediate is directly proportional to the rate of the reaction. If stability of the intermediate increases, right, rate of the reaction also increases. If product formation takes place with the stable intermediate, that is going to be the major one we have already discussed. Now let us see the types of intermediate, right? We have 9 types. One is carbocation, carbanion, free radical, carbene, nitrine, ylides, enamines, sigma complex and benzene, right? These are all types of intermediate. Now let us see all the intermediates in details. And now let us see what is meant by a carbocation, right? Generally carbocation is nothing but carbon with the positive charge. This is also known as carbonium ion, okay? Based on delocalization or stabilization of the carbocations, these are of two types. First one is classical carbocation, second one is non-classical carbocation. Now let us see what is meant by classical carbocation. These carbocations are stabilized either with mesomeric effect or hyperconjugation. For example, we have taken an allylic carbocation right over there. This will be stabilized with the adjacent pi bond, right? Delocalization takes place, pi cation delocalization takes place. What is happening here? We can see the mesomeric effect, right? Here also, this is the carbocation. What do we have? We have alpha carbons, right? Alpha carbons over there, and also we have alpha hydrogens, right? Here we can see the hyperconjugation. Because of hyperconjugation, stability of the carbocations increases. Because of mesomeric effect, right, stability of the carbocation increases. Here also delocalization takes place because of like mesomeric effect, right? Here these carbocations are stabilized by the mesomeric effect or hyperconjugation, right? These kind of carbocations are known as classical carbocations. Now let us see what is meant by non-classical carbocations here. Non-classical carbocations means these are stabilized with the C single bond C sigma electrons. How this will be stabilized? Now let us see here. This is the carbon. This is the carbon. Between this carbon a single bond is there. Single bond. Single bond means what? Sigma bond. The electrons which are there inside are sigma electrons, right? Now how these will be stabilizing this one? Something like this. See here. Yeah, these electrons, this single bond C sigma electrons are stabilizing this carbocation by a kind of delocalization over there. It forms a kind of center over there. This is 2 electrons, right? These 2 electrons are shared with the 3 centers here. That's what this is also known as 2 electron 3 center system. Okay, 3 center 2 electron system also. Okay. Generally, carbocations are intermediates in. We have already discussed that. Electrophilic addition reactions, and secondly we can also say SN1 reactions, E1 reaction, E1 elimination, also elimination, alkylation and acylation. Okay, intermediates are carbocations are intermediate in all this reaction. And now let us see about Carbanion. Carbanion is nothing but carbon with an anion. Okay, that is known as Carbanion. Generally, Carbanion is intermediate in all, generally in condensation reactions. For example, if you take aldol condensation, right? Aldol condensation. Okay. And we can also take Claisen condensation also. Claisen condensation. Okay. And the third intermediate is going to be the free radical. Third one is going to be free radical. We have already discussed what is that how free radical has been formed by the homolysis, what are the conditions are required, right? Intermediates, free radicals are intermediate in all kinds of photochemical reactions or free radical reactions. If you take for example, right, free radical addition reactions, free radical addition reaction, and free radical substitution reaction, in all these kind of reactions, right, free radicals are the intermediates. Now let us discuss about nitrates, right? Nitrates are nothing but nitrogen with two lone pair of electron, a kind of lone pair, and one bond pair electron over there, right? Altogether 6 electrons are there, and carbons are also will be having 6 electrons. That's what these are isoelectron with carbon. Acyl nitrate is an intermediate in Hofmann rearrangement reaction. This is about nitrate. Now let us see about ylide over there. Ylides are nothing but vicinal diionic compounds are known as ylides over there. Vicinal means what? 1-2 positions. Okay, 1-1 positions are known as geminal positions. We know that. Intermediates in Wittig reactions. Okay, now let us take carbon and particular element X over there. This might be anything over there, nitrogen, phosphorus or sulfur. Here what we have here. Okay, this is an example of intermediate in Wittig reaction. And now let us see the enamines, right? Enamines means what? Generally inorganic compounds in IUPAC nomenclature, what will be having? If single bond is there, it terms like suffix will be ane, double bond ene, triple bond ine, right? Here we have double bond ene, and here we have amine, right? That's what it is, enamine. These are example for Michael donor. These are intermediate in 1,4 nucleophilic addition reactions. Now let us see the sigma complex, right? Sigma complex are example in aromatic electrophilic substitution reaction. This reaction takes place in 3 steps, right? Formation of electrophile and formation of sigma complex and elimination of proton, right? Now when particular benzene ring, right, attacks the electrophile, after attacking, what happens? To stabilize the carbocation, right, what happens? Delocalization takes place, right? These three resonating structures are known as sigma complex, and final step elimination of proton and formation of substituted electrophile, philic product formation takes place over there. And now let us see the last one, which is known as benzene over there. Benzenes are nothing but the benzene, the whole benzene ring with a extra bond over there. We can take a triple bond in the benzene ring over there. Okay, it is an example or intermediate in aromatic elimination followed by addition reactions, right? Let us take a chlorobenzene with sodamine and liquid ammonia gives aniline, right? Let us see how the reaction takes place. When NaNH2 like added to this particular chlorobenzene over there, it abstracts the proton next to the chlorine over there, and it hydrogen gets out as a proton. That's what the electrons remains over there itself. And since chlorine is a good leaving group, right, what happens? A kind of delocalization takes place and elimination of chlorine takes place over there. When it takes place, right, what is happening here? A formation of new bond is taking place, right? We have a new bond here. This particular structure which we are seeing is known as benzene, followed by the addition of liquid NH3. What happens? We'll get additional product, that is aniline over there. Now initially what is happening? Initially elimination is happening, right? Proton is like hydrogen is getting out and chlorine is also getting there. This is the elimination, and followed by what is happening to this double bond is disappearing, right? Sorry, triple bond is out of triple bond, right? We have only double bond. Means what? One of the bond is reducing, means addition also taking place, right? That's what we are calling it as aromatic elimination followed by addition reaction. Okay, this is an intermediate in aromatic elimination and followed by addition reaction. These are all about types of intermediates. Thank you for watching.